All right, so now we have FRQ 2015 question number 3. And this right here was a no calculator problem, and it's dealing with this table. And so let's read it. It says, let's zoom out a little bit. It says Joanna jogs along a straight path for 0 to 40. And it says Joanna's velocity, so her speed, is given by a differential function v. Selected values of v of t, where t is measured in minutes, so that's her time, and v of t, her speed, is measured in minutes, meters per minute. All right, so the first question says, use the data in the table to estimate the value of v prime of 16. So what's happening right here is it's saying, what is the slope, because it has the prime, what is the slope at 16? Well, if we look at the table right here, there is no 16. So you're gonna have to pick two values where 16 would fall right in the middle, okay? So right here, that would be between 12 and 20, okay? So that would be our x value, and we're gonna use that to estimate. So when it says v prime of 16, it's saying take the derivative. What does derivative mean? Find the slope. So we're gonna look at the points 12 to 100 and 20, 240, just making sure that's correct. And then you're gonna use what you know about change of y over change of x, or y2 minus y1, whatever that's gonna give you, okay? So I'm gonna say right here, I'm gonna say 240 minus 200 all over 20 minus 12, and that's gonna give you 40 over 8, which is gonna leave you with 5. But if you look at it, we need to make sure, it doesn't say we have to have our units, but just to be safe, our y value is talking about meters per minute, okay? Divided by our minutes. So if people can't remember how to do their units, I usually say we have meters over minutes being divided by minutes, which is the same as meters over minute, times the reciprocal of this. So that's where you get your minutes squared. So 5 meters over minutes squared. Okay. All right, so that's for the first question for letter A. Okay, so now let's look on to letter B. So letter B says using correct units. It says using correct units, explain the meaning of this integral. Please make sure you remember that this is taking the absolute value, so that means we won't have anything negative in the context of the problem. It says approximate the value from 0 to 40 using a right-Riemann sum with the 4 subintervals. That's important to see. So right here, there's only 4 rectangles that you're gonna need, and right-Riemann means we're coming from the right side. And it says use it from the table. But let's do the first part. It says explain the meaning of this integral. Okay. So right here, it says from 0 to 40. All right, so the absolute value of that for dt. So this is talking about Joanna who's jogging. And from 0 to 40, that means in a total of 40 minutes. So after 40 minutes, we want to find the total. So anytime you find an integral, that means you're always talking about the total. So what we're looking for is right here. This explains the total distance in meters, because that's how far she's running. So the total distance in meters, Joanna jogs in 40 minutes. All right, so what's the total she jogs from 0? So in 40 minutes, what's the total meters? You get a point just for writing that. Now, the next part it asked is using a right-Riemann sum, okay? So some people can look right at the table right here and they can already find that right Riemann sum. If you can't see it all the time, then I always say make a quick graph to find your answer. So right here, I can make a quick graph that isn't always the accurate units, but it lets me know what's happening. So I have 0, 0. I'm going to just call that 12 and say this is 200. 20, I know it has to be higher than that, so I'm going to call that 240. I'm going to call that 24. Now, because it's the absolute value, you're not going to go down and put a negative 220. You're going to go up, and it has to be in between here, and it has to be a positive because you took the absolute value. And then lastly, this is going to be 40, 150. And just how you do the right Riemann sum, that means I'm coming from the right side. So that means from here, this is my height, boom. Start right here, this is my right. Make a rectangle. This right here is my right side, okay? And then my height is here, okay? So now you have your right Riemann sum where you can start finding the areas of these and multiplying it. So that means this area is gonna be 12 times 200, because that's the height, plus how far away is this and this? That's gonna give you 8 times the height of 240, okay? Plus 4 times 220, plus how far away is this? 16 times 150. Oh no, it's coming off. 16 times 150. And so because you don't have to worry about multiplying all this out, you can leave it just like that. And let's come down here and clean it up. Okay, and now let's check to make sure it doesn't ask for units. So for letter B, it says, approximate the value using a right Riemann sum with the 4 subintervals indicated in the table. So it doesn't ask us to do the units, so you can keep it right here, your answer, and keep it going, okay? So now let's look at letter C. And letter C says, Bob is riding his bicycle along the same path. So now we have another scenario for 0 to 10. So from 0 to 10 minutes, it says Bob's velocity is modeled by here. So this is his velocity, where t is measured in minutes. All right, so anytime you think velocity, we're in the middle graph, that's his speed. It says t is measured in minutes, and b of t is measured in meters per minute. So it's giving us the same scenarios like the table. It says find Bob's acceleration at time equals 5. So in your little set of notes, because I told you guys on the side, we need to make little set of notes. Remember, you have position, you have velocity, and then you have acceleration. So right now we have the velocity and they asked us for the acceleration. So anytime you're going from velocity acceleration, that means that you're gonna need to take the derivative. So right here, they gave us the velocity. We need to take the derivative of that, and it needs to be where t equals 5, okay? So let's write it. For letter C, it says b of t equals t cubed minus 6t squared plus 300. Okay, so let's find the acceleration, which is going to be 3t squared minus 12t, okay, plus 0. So that's going to go away. And then it says we want to go at t equals 5. So let's take the acceleration. Let's plug in a 5 equals 5 to the second power minus 12 times 5. 3 times 25. Honestly, I really want to know if we can just stop right here. But because it has units, then let's keep going. Okay, minus 60 equals 75 minus 60, which equals 15. And then right here, same thing, if you take the acceleration, so we took the derivative, so that means it's going to be meters over minutes squared. Okay. All right, so the next one, it says for letter D, based on the model from part C, it says based on the model from part C, it says find Bob's average velocity during the interval. Okay, so in your little notes, make sure you remember that average velocity is this right here. Okay, so right here, we're going to divide by the total amount, because when we're multiplying by that fraction, okay, so we're going to find the integral of our function and then find out once we divide by the total, what is that going to give us? So let's look at letter D. It says we're going from 0 to 10. So if we use that from 0 to 10, and it says we're going to put our velocity function based on C, t cubed minus 6t squared plus 300. Okay, so that's our velocity function. And it's going to be 1 over b minus a. So this is my b, that's my a, so it's going to be 10 minus 0. All right, so it's going to be 1 over 10. Okay, so we're finding the integral of this. So now that's going to be t to the 4th over 4 minus 6t cubed over 3 plus 300t. Okay, from 0 to 10. I want to make sure that's not in any of that. All right, 1 over 10 times t to the 4th over 4 minus 2t cubed plus 300t. And that's going to be from 10 to 0. Okay, so now we can substitute in our information. All right, so we're going to say 1 over 10 times 10 to the 4th over 4 minus 2 times 10 to the 3rd plus 300 times 10. Now, if we subtract 1 over 10 times, if we start substituting 0 into everything, you're going to see it's going to be 0 divided by 4 minus 2 times 0 plus 300 times 0. What you're going to see is all this 0 times this is just going to give you 0. So that's already done, and we just need to finish this information right here. So 1 over 10. I think they purposely put 10, so it's easier to calculate. So we're going to say 4 zeros divided by 4 minus 2 times 1, 2, 3. Okay, plus 300 and add another 0. Okay, and so lastly, let's finish it off. Okay, so this right here, we can bring it down. This right here is going to give us, oops, let's see if I can clean this up. I'm going to put my 4 in the bottom, and I'm going to put my 10 in the bottom. So now we're left with, excuse me. I'm over here messing up, y'all. What is this going to give us? 10,000 divided by 4. So it's going to leave you with 20 right here. It's going to leave you at 2,500 minus 1, 2, 3. Okay, so let's erase this. I'm messing up, y'all. Times 110. All right, so 2,500 minus 2,000 is 500 plus 3 is 800. So it's going to leave you at 800 times 1 over 10. And then lastly, divided by 10 is going to leave you with 80. Okay, so at the end for your final answer, have something wrong. 2,500 minus 2,000 plus this. What did I do wrong? That's 500 plus... Oh, crap. I knew it. All right, plus 3,000. So this right here is going to give us 500 plus 3,000, which is really, goodness, 3,500 times 1 over 10, which is really going to be 350. And that's going to be meters per minute. Okay. All right. All of that right here. A couple things I want you to remember is whenever you're taking the derivative right here, I knew that this was going to be minutes squared because we started off with the velocity function, and then when I took the acceleration, it was almost like saying finding the slope like we did earlier, the long process to find the minute squared times minute squared, or the minutes times minutes to give me minutes squared. Okay, now if you look at letter D, now we're going backwards. Okay, so it said right here, it's really supposed to be for the velocity, for the original function right here, it was really supposed to be meters per minute all over minutes again. So it was already minutes squared, but because we're going backwards, that means now it's just going to be meters per minute. This is the original function. Okay, so meters per minute. And that is the end of this video. Sorry y'all for me dropping that 0 right here.